Today we are going to learn about mastering alpha-beta pruning in game AI. You'll gain the skills to implement alpha-beta pruning to optimize decision-making processes in AI-driven games.
Welcome to our session on mastering alpha-beta pruning in game AI. In this video, we'll delve into an essential technique used to optimize decision-making processes in AI-driven games. Alpha-beta pruning is a powerful enhancement to the minimax algorithm, enabling AI to make quicker and more efficient decisions. By the end of this session, you'll understand how to implement this technique to significantly improve the performance of your game AI.
Game tree search algorithms are fundamental to AI decision-making in games. They simulate possible moves in a game and predict outcomes using a tree-like structure, where each node represents a game state, and each branch represents a potential move. The most basic form is the minimax algorithm, which evaluates the best move by assuming the opponent plays optimally to minimize the player's advantage. However, as the complexity of games increases, the sheer number of potential moves can overwhelm computational resources. This is where optimization techniques, like alpha-beta pruning, become crucial, helping AI to focus only on the most promising moves and disregarding less promising ones, thus improving efficiency. Alpha-beta pruning is a search algorithm that seeks to reduce the number of nodes evaluated by the minimax algorithm in its search tree. It eliminates branches that cannot possibly influence the final decision, thereby optimizing the search process. The alpha value represents the minimum score that the maximizing player is assured of, while the beta value represents the maximum score that the minimizing player is assured of. As the algorithm explores the tree, these values are adjusted, and branches of the tree that cannot possibly affect the final decision are pruned. This not only speeds up the decision-making process but also allows deeper searches into the game tree within the same computational resource limits.
While the minimax algorithm provides a fundamental approach to decision-making in games, it can be resource-intensive. Alpha-beta pruning enhances minimax by reducing the number of nodes evaluated. This is achieved by cutting off branches that will not yield a better solution than previously examined branches. By focusing on likely optimal moves and ignoring those that cannot affect the eventual outcome, alpha-beta pruning allows AI to search deeper levels of the tree without requiring additional computational power. This results in faster and more efficient decision-making, allowing game AI to perform better within the same time constraints. Let's walk through the alpha-beta pruning process step by step. Begin with the initial node, assign initial values for alpha and beta, usually negative and positive infinity, respectively. As you traverse the tree, evaluate each node's potential outcome. If a node's value fails to improve upon the current alpha or beta, prune that branch sees further evaluation. Adjust the alpha or beta values as needed when a more favorable outcome is identified. This ensures that only the most promising paths are fully explored. By efficiently navigating the tree and minimizing redundant calculations, AI can make more informed decisions, faster, optimizing its game-playing strategy. The power of alpha-beta pruning can be illustrated with practical examples in games like Chess and Tic-Tac-Toe. In Tic-Tac-Toe, the simple structure allows every move to be evaluated quickly, making alpha-beta pruning an ideal way to eliminate unnecessary calculations when an optimal path is recognized. In chess, despite its complexity, alpha-beta pruning significantly enhances AI performance by focusing only on the most promising moves. By pruning branches that do not affect the final strategy, AI can analyze deeper into game strategies within the same time, leading to better performance against human players or other AI. These examples showcase how alpha-beta pruning is not just an academic concept but a practical tool for real-world applications. Alpha-beta pruning significantly improves the time complexity of the minimax algorithm. The time complexity of minimax is OB to the power of D, where B is the branching factor and D is the depth of the tree. Alpha-beta pruning reduces this to OB-D/2, in the best-case scenario, effectively doubling the depth AI can analyze in the same time frame. This efficiency gain allows for deeper and more comprehensive searches without additional resource demands. By understanding this improvement, developers can better allocate computing resources, optimize AI performance, and ensure that their games run smoothly even with complex decision-making processes. Implementing alpha-beta pruning can be challenging, and several common pitfalls can hinder its efficiency. One frequent mistake is incorrect initialization or updating of alpha and beta values, which can lead to inaccurate pruning and suboptimal decisions. Another issue is poor tree structure management, which can prevent the algorithm from reaching its full potential. Effective debugging involves carefully reviewing node evaluations, ensuring proper value updates, and confirming that pruning decisions are logically sound. By understanding these pitfalls and applying robust troubleshooting strategies, developers can fine-tune their implementations for optimal performance.
To implement alpha-beta pruning effectively, let's explore coding examples in popular programming languages like Python, Java, and C++. In Python, the recursive nature of alpha-beta pruning can be easily expressed, thanks to its concise syntax. Java provides powerful object-oriented features that help structure complex game trees, while C++'s efficiency and speed make it suitable for performance-critical applications. Each language has its nuances, so understanding language-specific best practices is crucial. We'll walk through code samples, highlighting key aspects of each implementation, and provide tips for optimizing your code across different platforms. These examples will equip you with the practical skills needed to bring alpha-beta pruning to life in your projects.
We've covered the essentials of mastering alpha-beta pruning in game AI, from understanding the basic principles to implementing practical examples across various games and programming languages. By integrating alpha-beta pruning into your AI strategies, you can achieve more efficient decision-making and enhance game performance. Remember, the key to success lies in understanding both the theoretical concepts and practical applications. With this knowledge, you're well equipped to tackle complex game AI challenges and continue your journey in game development and AI optimization.